trends, various trends, and what are the recent EVs, and what are the charging station architecture, what are the standards can be followed for a charging EV. Okay, this I'm going to discuss in this today's section. Also, in the final section, we will be discussing about what are the module we developed. We developed our own vehicle. That everything we will show you in the final hands-on section. Okay, now I'll move to this recent EV. What is the EV is available? That I'll discuss today. If I'm coming to this, okay, you know what is the use of what is the need of EV? EV is because it's the pollution-free transportation system. Also, it is more energy efficient and it provides a simple drivetrain mechanism. That is the reason, and we are moving towards a even government. Everybody is saying we need to get a sustainable environment. That is the reason we are moving towards a EV. If I'm coming to the EV section, okay, how the EV generation, how the EV is developed. That if we are starting from 1834, the first EV is developed. Okay, that is developed with actually here I'm not going to cover based on the EVs, which EV is developed. Actually, which type of battery, then how the charging station is used. That I'm going to discuss in this presentation. If I'm coming to the first EV, the 1834, the first EV is developed, which is uses a non-rechargeable type battery. Okay, then next level of the EV is developed in the year of 1874. That is of lead acid battery that can be used. Then next level, okay, they are using the batteries in the 2000, okay, 20th century. They are using the batteries of VRLA, valve regulated lead acid battery, and permanent magnet synchronous motor. These lithium ion batteries, cobalt lithium ion batteries, these are the booming level of the EVs. They are using a EVs with lead acid battery. They are driven a vehicle with single charge. They are driven a vehicle of 100 kilo, around 144 kilometers. The capacity of the battery is 100 kilowatt. If I'm coming to the next battery, they are using a different battery, cobalt lithium battery. They are show the progress level. It is increasing level of the kilometers as well as that with the various variation in the battery in lead acid to then migration to lithium based batteries in around 62 kilowatt of batteries in use. They are driving kilometers. The next level of the battery. Now we know that's why they are developing a advanced level of the battery. That vehicle, they are driving a recent vehicle around 310. Around 2017 itself, they are developed 310 kilometers. Now they are driving a range of more than 500 kilometers. First, if I'm coming to the Indian market, they are developing a EV that is developed by Mahindra company. That is an Indian company. They developed Mahindra ETO NXT. That is a driving range of 120 kilometers. They are driving in this vehicle. Also, the recent EV they are developing Mahindra as well as Tata. We can see nowadays, we can see everywhere the vehicles are available. That vehicles ranging everything, the specification I given for you. Based on that vehicle only, I'm going to discuss about the charging, what are the charging connector that I'll discuss with you. Then if I'm coming to the vehicle, okay, various types of vehicle is used. You all familiar because you are electric vehicle, but the type of vehicle it's developed, whether it's a plug-in electric vehicle or it can be a pure electric vehicle or which can be a combination of hybrid as well as electric. Now the trend is going towards a pure electric vehicle. There is no need that development is more in a electric vehicle. Mostly we are focusing on pure electric vehicles. Even two-wheelers, everything is coming in a pure electric format. Then if I'm coming to the change in India, the sales and how the growth is happening in India, you can see the growth in year-wise. If I'm seeing the growth of 2013 and 14 and all, the growth is very less. The vehicle, because the battery is that time only we are not familiar in the lithium-ion batteries. The lithium-ion batteries are lithium ferrophosphate batteries. That energy density of the battery is very low. That is the reason they will go for a lead acid battery. That and all they use. From coming to the level of the battery, battery production, everything is increasing. Due to this reason, the growth is increasing. The growth is increasing. Not only the based on the batteries, then charging facility. If I'm taking a vehicle, where I can charge my vehicle, that is important. Whether if I want to travel around 120 kilometers, then where I can travel, where I can charge my two-wheeler, that is very difficult task. Nowadays, we can see the charging station everywhere, it's available. Then how the connectors, it is adapting for my vehicle, that is following the standards. That only we are going to cover. If I'm based on this only, based on the standards, the developed EV growth is increasing. How the growth is, that is 200% of the growth is increased in 2022. Now the growth is high much very increasing. Now if I'm coming to this graph, the graphical representation, how the projected graph towards the financial year of 2030, you can see then how many around 25 million new sales they are projecting towards the year of 2030. Then based on the available strategy. Then if I'm coming to the various challenges in the EV technology is there is a road if I'm coming to the battery based EV charging station, the battery weight is more constant. Okay, if battery weight, if I'm following a lead acid battery, the battery weight is huge. If I want to use the 100 Ah battery, the battery weight itself is coming around 40 kgs around. Even we know the batteries which we are using in a house itself, in the inverter battery we are using. That battery weight itself huge. The same type, same capacity of the battery, if I'm making in a different combination of chemistry. For example, if I'm using a lithium-ion batteries, the size and weight, everything is reduced because the weight is major impact on the EVs. Then I'm going to the charging time. According to the charging time, which type of charger I'm using, and which type of converter I'm using. Based on that, the charging time will differ. Directly, if I'm connecting, if I'm developing a converters, then how the charging it happen? I can have to convert the AC to DC. The DC can be DC conversion. It should be capable of charging the battery. Then if I provide a maximum current, that is the C rating of my battery. If I'm providing the maximum current, then only the battery will charge immediately. If I'm providing less than the C rating, if my battery charging current is 5 ampere, if I'm providing 1 ampere, then the battery will take more time to charge. That is the one we discussed in the levels of charging. Then providing a rated current, we can charge easily and we can charge faster. That is the reason the charging time is one of the challenges. Then if I'm coming to the distance, then how can we increase the distance of the electric vehicles? If I'm increasing the distance, we have to use the energy storage capacity as much as possible. How much capacity of the battery we can install in a vehicle, that is one of the important challenge in the electric vehicle scenario. Then if I'm coming to the charging power management, okay, why we are going to the power management? If I'm connecting the vehicle, if I'm connecting the vehicle to public charging station, it is not taking a small amount of power like your 2 or 3 wheel. It will be taking the power in terms of kilowatt. If I'm connecting n number of vehicles, how the power will be taken from the EV general grid, then it can create a demand in the grid system itself. It is that itself, it will be a huge impact. Already we are talking about the sustainable development, sustainable EV. Then we are moving towards the EV for sustainable, but the power we are getting from thermal and the various power plants, that is not from a sustainable development. Then we need to manage. Actually, the grid impact can be managed as well as it can be integrated through PV. This can be addressed. Then how can we address this one? Then we should have a proper charging station control as well as proper power flow we should address. Then only we can get a proper grid connected EV charging station. Then only we are able to provide an appropriate solution for this EV charging. Then if I'm coming to this next one. Okay, these are the recent EVs. I have taken what is the EV it's available. What is inside the EV? Okay, if I'm taking a EV, the structure of the vehicle they are developing same like uh, ICE based vehicle. Okay, but what is there? What is there in front of the vehicle? Where the battery is fixed? What is the range it covers? That we will discuss. If I'm coming to this vehicle, actually this is the vehicle they developed by Mahindra company. It's a XEV 400. Model number is XEV 400. What is the type of what's the type of battery they are using? See here, where what first of all you can see the picture. See the picture here. This is a picture. This is a picture. This is the front portion of the vehicle. This is the front portion of the vehicle. What is there? Same like your IC engine. What is there inside this? We can see some liquid tank here. We can see some mechanism. Actually, like an engine, we can see some mechanism. What and all is present here? And where is the battery? Actually, as per this specification, the vehicle, this is the type of the vehicle. This vehicle, they are having a battery in the bottom of the vehicle. But what is this one is this is for controlling mechanism. Actually, the battery is cooling system is provided. For this battery, the cooling system. Some of the batteries are cooled through the air-based system. Some of the batteries oil-based system they are using. Some controllers, then we are using a controller. The controller also they are provided a cooling system. Apart from the controlling part, they are providing a cooling system for this controller also. Here they've installed for controller as well as the mechanism, everything they fixed here, motor, everything they fixed here. But the battery is placed at the bottom of the vehicle. Okay, what are the specification of this Mahindra XEV 400 is? They are using a permanent magnet synchronous motor. Okay, as we know, since we are while we are using a electric vehicle, for example, most of you familiar about a two-wheeler. If I'm using a two-wheeler, they are using a BLTC motor. That BLTC motors only we will be using for low power application. For example, two-wheeler, three-wheeler level, we can use a BLTC motor. If I'm going for a higher level, high power level, then we have to go for some high power capacity of the motor. The permanent magnet synchronous motors are used. Okay, as an electrical engineer, we know why we are moving towards this type of motor. Then if I'm going to the specification, what is the range it covers? If I'm coming to this vehicle, it can covers 456 kilometers. What is this MIDC? MIDC, it's a testing range. They develop a under particular condition, modified Indian cycle condition they did. Based on that, they developed this. They are project. This is an 456 kilometers of per charge they are driving. Then they are saying in the vehicle itself, they are saying different modes. What is the modes of driving? How can we control our controllers? That is also important. If I'm driving modes means I can change the modes. What it can do. Then what is my controller has to? Then if they are saying fun mode and fast mode and fearless mode. What is this mode? What is we can give a command? What type of command we can give to the vehicle? For example, if I'm taking a fast mode, then it cannot. It should run at fast. Its acceleration will be very faster, and only we can say fast mode. Actually, some modes we cannot. We cannot run beyond the range. For example, we know even in IC engine we know the limit, the maximum speed limit we are able to control by adjusting some of the valves. We are able to adjust the limit. Similarly, here also they are controlling. Actually, this fun mode and they are controlling the maximum speed and fast mode. What is the fast mode? They can accelerate very fast. Then they can drive very fast. In the IC engine, they used to say sport mode. In the sport mode, they are able to drive very faster. Then the acceleration, the pickup is very high. That is the one. The fearless mode, then it is a fearless mode. Then we should they can say that is a L mode. What is it? L mode, single pedal mode. They should not have any regenerative braking. Okay, they are using in other modes and all. They are using regenerative braking. In this mode particularly, They are using a pedal system, only one pedal system for controlling acceleration as well as deceleration. They are controlling through this single pedal system. This everything can be controlled through this. If I want to control through this fearless and L mode, then I should give only single pedal system. Then that can understand by the controllers as well as converters. Then this is one of the work in the electric vehicle. Then how much battery capacity they are using in this Mahindra XCV 400? Here the battery capacity of 39.4 kilowatt hour battery they are using. High energy density lithium ion battery packs using. Okay, this is the battery capacity. Then what are the charging it can support? What are the charging it can support? Somehow they used to say these are the different types of charging. One is CCS. These are the different types of charging. What is this? This is CCS one charging. The CCS one charging is a combined charging system. Combined charging system one. The next one is a combined charging system two. What is combined charging system? They may use both AC and DC. Combined charging system, they may use both AC and DC. What is the range of connector? What type of connector we can use? Whether we are using the same type of connector, what is the standard followed in the connectors? That we must familiar. Then only we can design what type of input I'm getting for my converter. What is the converter has to do? Then how much it can be stored in a battery. Then if I'm using an onboard charger, for example, if I'm using a AC charging system, we must have a charger inside the electric vehicle. If I'm using a DC system, we may not require a charger inside. We may not require any kind of converter inside the vehicle itself. Okay, this is a different. Okay, here AC we need a converters inside the vehicle. In DC we may not require a converter. Based on this one thing, we have to select a converters. Okay, which type of converter, which type of connector we are going to employ in our vehicle. This we must familiar. Then if I'm coming to this next vehicle, this is another vehicle. This is this vehicle is also most familiar vehicle. This can be driven 312 kilometers per charge. 312 kilometers per charge. The battery capacity, and here also the permanent magnet synchronous motor can be used. Then high energy density lithium ion batteries are used in this vehicle also. Then these are the various specification of the this Tata Nexon. Already I explained. Then if I'm coming to the connector, we can see the connector like this. Okay, what are the pins? As per our knowledge, actually this is I've taken from one car reviewing website. This portion, what is this portion is called? Then we can see these are the connectors are available. This connector will plays a major role. What kind of communication, actually what kind of supply I'm going to provide. Actually, as per this Mahindra XCV 400, I told you this is available with AC as well as DC. Then this is of CCS, combined charging system 2, both AC and DC supporting. Then where the AC is connected, where the DC is connected, that only. Then based on the AC and DC system, the charging time also is very clear. Then if I'm coming to the same thing, the Mahindra XCV only, I given a picture. Then based on that, it will be taking the time to charge. Okay, if I'm connecting for charging, okay, I'm connecting for the charging DC fast charger. Then how much it's required? It's required a 15 kilowatt of input. It's required a 15 kilowatt of input. If I'm providing this 15 kilowatt, it can charge. How much it can charge? From 0% to 80%, it can charge in a 50 minutes. Okay, in a 50 minutes it can charge. If I'm using a 7.2 kilowatt or 32 ampere charger, okay, if I'm using a 7.2 kilowatt 32 ampere charger, it can charge around 6 or 30 minutes. It can charge. It will be charging 0 to 100%. Okay, these are the various range. Then what is this type of connector where I can connect my DC? What is this point? What is this one? We need to understand. If I'm designing any kind of charger for my battery, what are the feedback I need to receive? That and all we need to understand. If I'm coming to this, I'll show you. different types of connector with different standards, what it followed in different countries. I'll show you in a coming slide. And if I'm coming to the charging mechanism, that type of charging mechanism they are using, how the picture of the charging mechanism it's available in Indian countries as well as in foreign countries. If I'm coming to this is a home-based charging system. This is a charging system at a public network. This is a renewable-based charging station. Then you can see this is a charging board. Actually, they are developed a wireless charging LAN. They are developed in UK that are in a testing mode. They develop a separate LAN for a wireless charge. Apart from that, many researchers, including our laboratory, we are working on the charging here. We are also developed a charging LAN. We are charging a batteries here. Then that design, everything we will be explaining in upcoming lectures. Then if I'm coming to the next concept, how the charging station can be addressed, how the charging can be avoided, how the electric vehicle range can be, how the electric vehicle usage can be maximized through this battery swapping station. What they will do, simply they will change their batteries. How they can change the battery? Okay, if I'm giving a battery of my battery is of 10% of charge, but I'm exchanging it. Some of them they will come. It may be with a charge of 20%. They can replace their battery. Some of them come with a battery. Okay, I may not get a charging station in between. Okay, for example, if I'm traveling from Chennai to Bangalore, I can find a charging station in a range of 100 kilometers and can find a charging station in the range of 100 kilometers. I have to travel 500 kilometers. If I'm getting a charging station here, for example, I'm starting here my battery itself, it is having a 60%. If I reach this place, my battery is fully gone. Then I may not be able to may not be able to change my battery. Then in that case, I can exchange my battery with this 50% itself. How can we charge this battery? How can we exchange this battery? We know we can exchange the battery. How can we fix the pricing for the battery? That is also one important task. If I'm coming for a battery swapping station, that is also one important task. How we can fix a battery, how the age is, how long I'm using this battery, how many days I use this battery. That is also important. Based on that only, we can fix the pricing. How the pricing and all can be done. The pricing can be done based on some intelligent algorithm. We can write a program. We can find how much then we can fix in the battery itself. The health code kind of mechanism we can fix in the battery itself. Then we can replace our batteries. Okay, then only it is possible. If I'm coming to this type of mechanism, then it is one research work. This stage many researchers are working. This is one type of solution for this addressing the EV charge. Then likewise, some companies like ABB, they recently shown one video. In that video, they showed that's a flash charging. As of now, I discussed about a simple charging mechanism. We know about connected charging and wireless charging. They are connected by flash charging. What is that flash charging? From coming to the flash charging, then they will connect like buses. Okay, they are stopping in a 2 to 1 minute, maximum 1 minute. They will stop in a bus stop. During that time, they used to charge in 20 second or 30 seconds. They need to charge the battery. Then how much they are charging? That and all they are testing. The company ABB, they are testing this flash charge. That is one type of charge. Then what is the requirement for charging? Okay, if I'm connecting for AC, I need to have a converter topology. If I'm connecting for DC, I need to have a dedicated supply equipment. This I can connect it from home. This I can connect it for EVSE. Somehow we need to say it is EVSE. What we need, electric vehicle supply equipment meeting. Here we can have a charging port. It's like a refilling station. We may have a charging port. How much power it is given, that we need to match. Then based on that, the connector, the male and female connector are fixed. That connector it has to match. Then it may damage the battery capacity. If my battery capacity is 5 ampere, then I cannot provide then 10 ampere here. It has to match. Then only it can charge. Then I have to get a feedback from this battery also. If I'm using a electric vehicle supply equipment. directly if I'm coming to this onboard and offboard charging, you may clear about this. But and all it will be available in the charging environment. If I'm coming to this charging environment, we we have a protection circuit. Then we need a DC to DC DC to DC conversion. Then only we are able to charge this offboard charging. If I'm coming to the onboard charging system, we need to design a converter. The small level application and all. If I'm coming for a small level application, directly we can develop. If I'm using a two-wheeler, directly I can plug my AC supply system directly. I can use a simple rectifying mechanism. In that itself, they are able to charge. I'm going to the higher level, higher power level. That cost, the weight of the vehicle also it is increasing by using a charger inside the vehicle. And then these are the various levels of charging. We know what is various levels of charging. In AC itself, we have a 3 levels of charging. In DC also, we have 3 levels of charging. Based on the voltage and power rating, they used to say levels of charging. If I'm coming to the level 1 charge, what is the level 1 charging? This is where we are using this level 1 charging. Level 1 is a portable charger. Just we need to plug into the AC supply system. Directly we can plug into the AC supply system where we will use. Actually, how long it will take? Actually, it will be delivering current of 16 ampere. How much charging time it will take? Charging time approximately 7 hours charging it will take. This is the onboard charging because we are connected to the AC supply system. Then it will be home-based charging system. Just we are able to use it in our home itself. If I'm going for a level 2 AC charging system, it can be a range of 208 to 240 volt. This is also again single phase AC system, single phase or 3-phase AC system. This is again a onboard charger. It's the dedicated converter used inside the vehicle. Then if I'm coming to this standard, what is the type of connector I have to? Standard J1772. This is the AC standards they have to use. Then if I'm going for a high power level, that is the AC itself, if I'm connecting for a high power level, that can be operating voltage of 300 to 600 volt. The power rating approximately is given 120 kilowatt to 240 kilowatt. How much time it will take? Approximately 30 minutes they are presented here. Then it is also onboard charge. Then this charge the more standard they are using, the standard connector they are using. If I'm coming to the level DC levels of charging, if you're coming to the AC level 1 charger, it will be used in a home-based charge. If I'm coming for a AC level 2 charging, it can be used in a residential building. You can see in apartments and everywhere that is an residential place. They will fix a charge in the parking lot in companies. They will fix this type of charging. That is a level 2 charging. Directly they will connect in this type of charge. If I'm coming to the next level 3 charging, that's the charging station dedicated charging station can be developed for this. If I'm coming to this DC level charging, where they will use, how much time it will take? Approximately 20 to 30 minutes they will take up for charging. That is using electric vehicle supply equipment. It's following the standards of charging. Then if I'm coming to the standards, what is standard? What it can do, what it can define. That is defined based on this simple example. What is this? I've taken this one standard. Many more standards are available. If I'm using a wireless charging or wired charging, both what is type of charging I'm going to use based on that standard may differ. Okay, if I'm using this charger as this standard, this is the International Electrotechnical Commission standards 62196 standard. Here, this standard defines there are 3 modes of charging. What are the 3 modes of charging here? See, this first one is a mode 1 charging. What is this mode 1 charging is? They can connect with household charging, household supply. This connector, we can connect this as per this standard. We can connect with the household supply. It cannot have any safety mechanism. This may not have any safety mechanism in the connector itself. But we have a mechanism. But we have a MCB and fuse circuit in our home itself. But it is not reacting very fast. Okay, if it is a major fault, if I'm getting a short circuit in the wire itself, then only it will create. Then only it will protect the circuit. If it is a this kind of mode 1, then if I'm coming to the mode 2 in the IEC standard, this standard it can be have a dedicated mechanism. It can be uh, control and protection system in a cabling system itself. This will have a protection system that can be used in the household outlet only, but it has a protective mechanism. Then if I'm coming to the third mechanism, that is a mode 3, that is a dedicated electric vehicle supply equipment. It can be used that uh, it can charge. Okay, it can charge with communication, everything it can be provided. Then next one, DC charger. The mode 4 is a DC charger. Directly we can connect the DC supply system that can be charged. Actually, this with all the cooling mechanism, everything is provided in this. Also, fast charging option it is available wherever we are using. That we have to follow this IEC 6219 standard. What are the various standards it can be used? Actually, I told you this is one of the standard that defines in particular country. So I'm coming to this standard. Okay, from SAE J1772 J 2293. Likewise, like year wise they are developed the particular type of charging. This is for J1772. It's for conductive charging, which the year is developed by this standard is 2010. Then likewise, there are different standards for wireless charge. Then wired charge. If I'm coming to the J28472, it is both. It is for both conductive as well as inductive charging. It is developed in the year of 2015. Then for battery swapping, actually we know the inductive as well as conductive charging. Yeah, for battery swapping also we have to follow IEC 62840. Then what is the general overview? What is the battery general overview? The voltage matching, then capacity matching, everything it has to match. Then only it will be, it follows this standards. Then these are the various standards in the electric vehicle charging station. Then what is the connector? Okay, if I'm coming to the connector, these are the connector pins. Okay, then we have a AC as well as DC. This is the AC portion. This is a DC portion. DC portion we have a 2 pins only. Then apart from that, even if I'm going for AC portion, we have 5 pins here. What is this 5 pin? Actually, this 5 pins for various communication as well, communication purpose. How much my battery is charged, how much my battery is available. That everything is communicated through this communicating port. Then if I'm coming to this charger, actually this is for Mahindra vehicle connector only. This is the type of Mahindra vehicle connector only. Then it will be provided. Then cooling system, everything it will be provided. And cooling tube, everything will be provided in a charging gun itself. Then here we can have a male and female connector. It has to match. That is the shape of the connector it's given. Then what is the type of charging they are using? The rapid charger, fast charger, slow charger, and flash charger. Recently they proposing the flash chargers. Then what are the different countries? They are following different standards and different connectors, everything. Like we know, while we are purchasing a mobile phone itself, we can found the connectors. In Indian country, we can purchasing, we will get a certain type of male plug point. Then if I'm purchasing a mobile phone charger in foreign countries, we can find some other countries, we can find plot type. Then it's not that, then standard they are defining in a connector. It's the same way like a mobile phone, they are developing a connector also. That is a USA standard, Japan standard, Europe standard, and China standard, and everything. They are using different types of standard. Then this is the standard used in the standard types of connector used. Then what are the standard they are following in a connector? This we have to follow. If I'm designing any vehicle, we have to follow this particular type of connector. We have to follow. Then what is the comparison of this connector? If I'm going for a different types of connector, which connector it can be providing, which can be allowing maximum power rating. As per this comparison, the China is developed. Actually, it can be supporting 900 kilowatt power. It can be able to transmit by this GB per T this connector. Then it can be able to transmit. What are the communication? How many number of control pilots are available? 2 control pilots are available. Then CAN bus can be CAN bus communication. It's available here. Then various specification they are given. Okay, here this is the one it's providing maximum power rating. Then if coming to the next one, flash charging. I told you flash charging it's developed. It can be charging in a 20 second. For a 20 second, it can charge in a parking slot. Okay, the bus is coming. Then this bus is they are calling as a TOS, a trolley bus system. They are calling as a trolley bus system that developed by ABB. This available for your clear understanding how the charging mechanism is shared here. That I'll share you another video page. I'll share with you. One second. See, there's a video for this trolley bus system. For trolley bus, they can have a separate mechanism. It has to match, and then they can transfer a 600 kilowatt supply. Then it can be charged around 30 seconds, 20 seconds. Likewise, how much duration they are stopping in a vehicle in a bus stop. Based on that, they are charging. They are developed this kind of mechanism for their uh, electric bus, then passenger transport bus. Then what and all it's available in that system. Then battery unit it's available on the top of the system. Then connectors, then how the electricity is connected without power. Then everything they are connected. Then how the various mechanism is working. That and all it's shown. This is the specific bus they are developed by ABB. Then this is about recent flash charge. Then how many charging stations we can charge our vehicle. That everything is proposed in this. Then if I'm coming to the uh, topology, and if I'm coming to the charging station architecture, in the previous lecture itself, Tariq explained very well about charging station architecture. You all familiar. In this case, if I'm connecting a charging station, what are the various sources may be present? Okay, we know the sources may be PV or wind or energy storage unit or any generator, local generator they can connect because it can be manage the grid system. If I'm connecting to an electric vehicle of 50 kilowatt, then the grid system will get demand. Then it will be compensated. Then how we can compensate? Then if I'm having a energy storage unit as well as the renewable energy system, then only it is possible. Here, with the sources, they propose different types of charging station architecture. It is available practically as well as based on the literature. I studied different um, architecture. Okay, this architecture various combination actually where they are implied. Then what is the power rating? Then that is important. If I'm choosing particular power rate, based on that only I have to choose my generator. Then if I have to choose my energy storage unit, then only it is applicable. If I'm choosing a improper range of power system, it is power rating, then it is very difficult. Then if I'm coming to this one, this is isolated DC microgrid system. If you are in a remote location, then we can install this type of station. For providing uninterrupted supply system, they have installed this biofuel generated system. They are proposed a converter, particularly the person they are available, they are researchers, they presented a dedicated converter for this connecting bio fuel generator, then energy storage unit. If I'm using particularly for isolated microgrid system, what is the converter I have to use? That can be used. Then dedicatedly they are using a DC bus system. Then they will be using a DC housing in the isolated microgrid itself. There is no need of any conversion. They will be using a dedicated supply equipment. If I'm coming to the next methodology, next how they are connected. If they are using a grid connected methodology also. Grid connected means the DC bus can be connected to the grid system. Then here the energy and power level can be managed. Then this we can call it as a grid connected DC microgrid system. Then if I'm coming to the next one, only say you can observe the difference here. Here the PV and the energy storage units are employed. Then the same way grid connected employed grid connected. See, there's a grid connected energy storage grid connected DC microgrid system. Here the DC bus is employed. Then how much voltage we have to follow for this? If I'm coming to this, the grid connected with USU, the USU energy storage unit will be supplying power. Then if I'm coming to the next charging station architecture, USU it's available. The bus system they are following a AC bus system because most of the equipment, maybe they may be having an industry, part of their having an industry, then they will install, they may be installing this AC bus system. They are not, their focus is not particularly on EV. Some more application they are running. That is the cases they were using a AC bus system. Then if I'm coming to the hybrid bus system, this where it's applicable. There are many researchers. Like we find this type of charging station architecture in real time. Many researchers in local level, they are developing a laboratory. They may have a AC as well as DC bus system, but they can combinedly they can use all the sources. Here for renewable energy, all the topology I've shown only PV. Apart from PV, we can connect the wind also. I didn't show that. There are many topology they showed wind also. Then that time they will use multi-port converter topology. This is also in the research level only. The multi-port converter, that if they are using a 1 kilo level, they will use multi-port converter along with PV, wind, and energy storage unit. They can connect 2 to 3 batteries. When one put out one converter itself, they can develop a particular electric vehicle supply equipment. That itself, it can charge our electric vehicle. That is also, we also developed a dedicated converters for particular lead with 3 electric vehicle, 1 PV, 1 energy storage unit. We developed a converter topology. We are also working on that field. Then if I'm coming to this next, only multi-port converter with AC and as well as DC, the researchers are working. The AC bus topology system, AC bus system, and DC bus system, they are having a different topology. If I'm making a comparison of all the topologies, the one which we have a direct AC source, we are having a second topology. I showed you the DC bus system with renewable energy sources, energy storage, and grid integrated topology, mostly used in various real-time applications. Then what is the main focus on this? What we need to focus about this charging station architecture. So I'm coming to this charging station architecture. We have to do the power management. How the power flow, which direction the power flow will take, whether it's from energy, renewable energy to electric vehicle, or energy storage to electric vehicle, which direction the power flow it will happen based on the availability, and based on that only it can be decided. And this is what we need for a charging station architecture. Then if I want to do that one, this is one of our work we did in energy management stated. Then if I'm coming to this energy management, this is the overall setup we developed in our laboratory. Then simulation study we did, as well as we did for practically, we developed with small battery capacity, we developed this mechanism. This will be tested. This is tested in our laboratory itself. Various feedback mechanism we have taken in this charging station architecture. We provide a PV system here. Then we connected a DC to DC converter. Here we are maintaining a DC bus voltage. All the converters. For example, if I'm taking this PV system, this converter is producing an output that is maintained through the boost converter. Then here we used one isolation switch. Through this, we are connected to the DC bus system. Then similarly, we are connected to the grid also. The grid can be connected to the bidirectional AC to DC converters. These converters will be connected to DC bus system. This DC bus system, it is ranging of voltage. When I am connecting to the pure photovoltaic system, that photovoltaic system will be providing 50 to 320 volt only. Then it may be, it is a morning section, morning duration, early morning around 8 o'clock. It may be giving a supply of 50 volt only. The range will vary. Then that time what we need to do, that analysis, then I can provide a supply from the energy storage only. Then grid bus voltage, DC bus voltage must be maintained. Then only the charging system will be uninterrupted. That can be maintained. This is one important research work. This is one of the research paper we did. Then DC bus voltage maintaining, DC power level, power management is the important task. In the here itself, we can apply optimization. Then how this bus voltage is regulated. For example, we can apply different optimization, as well as we can apply a fuzzy based controller here. That that can be applied in this particular system. If I'm coming to this, various modes of charging can be done. For example, if I'm coming to this diagram itself, this pictorial representation itself, we can see the power flow, how the power flow is happening. Either I can transfer a power directly to electric vehicle instead of storing into the energy storage. Actually, we have a PV local load. Actually, I have my house, actually small AC house is developed. Then 3 charging port we kept, then 1 energy storage unit we kept. Then how the PV supply system effectively utilized, whether it can be stored to the energy storage unit, or if the EV is available, whether we need to detect the EV, then if it is a EV is available, then we can charge the EV. Suppose if I'm having a EV, but I am ready to transfer the power, this vehicle is a bidirectional converter. If I'm having a battery with this as a bidirectional converter provision, then I can transfer my power to the grid. Okay, I can transfer my power to the grid. Okay, these are the various feasibility we tested in this research article. There's a simulation study. These are the data we have taken for a simulation study, but we developed a 1 kilowatt setup for this testing. These are the various parameters. Actually, these are the various parameters we have taken for this analysis. Then if I'm coming to this mode, okay, based on the power, we assigned 11 modes. What is the modes? How the power flow? Whether PV is dominating, which is dominating, PV or energy storage unit is dominating, then either vehicle is dominating, which is dominating. Based on that, we developed 11 modes. All the modes we tested here based on the power flow, how much power capacity is planned for the particular vehicle. Based on that, we planned modes. Then we showed a power flow here. You can see if I'm having a, for example, I'll explain only one mode. See, PV power is less than the PV reference one. We will fix up a reference. Okay, for example, if I'm able to charge, if I'm producing some power capacity of, for example, my EV is 1 kilowatt. Each EV is of 1 kilowatt. Then if I'm coming to this PV's capacity, if it can be capable of generating supply for both charging of electric vehicle as well as energy storage unit. If suppose my energy storage unit, I need to design how much I can design my energy storage unit. If all this depends on my electric vehicle as well as my battery capacity. Electric vehicle as well as my PV panel. Then how much I can store in a battery. For example, if I want to, if I'm considering a 1 kilowatt of electric vehicle, I must have a 3 kilowatt battery system. Then only I'm able to charge at least in a port one time I'm able to charge. Then apart from that, how much I'm going to store. Then that is also important. Here this can be how the power flow. Here this will be power flow. Then the red color one I showed you. The red color one. Each mode the power flow is shown here. Then power PV less than equal to power PV reference. For example, I've taken this PV reference as one vehicle charging the PV reference. That is a minimum value I fix. Then if I'm able to charge this PV reference values, one vehicle only it is to charge. PV supply, one vehicle only it's able to supply. That time the energy storage unit will be supplying the power to all the vehicle. PV power along with the energy storage power will be provided. Likewise, we can fix up a modes. Actually, then based on the practical condition, we can analyze the practical condition. We can fix different modes. That modes and how the various charges, how the charges is happening. That we tested in this various modes. These are the various modes we derived in this charging station architecture. We tested practically as well as we tested in the simulation also. This is a paper, it's available in MDPA. That also you can check for your reference. Then how the is following, then what are the various movements? This picture is not that much clear. You can refer the flow, how the flow is happening. What is the condition we set? That and all it's shown in this picture. This is a complete operation of this charging architecture. Then for your understanding, I'm showing you as a part. This is the first part. This is the second part I'm showing. This is a charging station part. This is a vehicle part. Then this I'm showing here as a upcoming two slides. You can see various parameters. Power reference 1, 2, 3. Then what is the SOC value of vehicle? Then what is the EV value, PV values? Then everything we have taken. Then what is the current? What is the current? The grid current, distribution transformer current. Everything we have taken into consideration. Then we maintain the power DC bus voltage. We maintained here. You can see this is the DC bus. We maintained here. After the DC bus, we used to charge from the DC bus. We used to charge the we charge the vehicle. Then which charging mechanism we have to follow? Either we have to go for a constant charge, constant current charging, or constant voltage charging, which is which can be adapted. That can be selected through the control system. That can be selected. Either if I'm having a less than 70% of my SOC, then I can go for a less than 70%. I have to go for a constant current charge. If I'm reaching the greater than 70%, I have to go for a constant voltage charge. This can be decided for all the electric vehicle as well as for energy storage unit. Then if I'm coming to the research perspective, then what are the ways they can do research in this charging station architecture as well as in battery swapping, then various converter topology. If I'm coming to this distributed energy sources, we have this various systems, okay, like a PV and electric vehicle. In between, we need to manage many things, okay, like we need to maintain a building, we need to manage a data transfer. For example, if I'm taking a battery swapping, whether battery swapping is swappable batteries are available or not, that I need to check. Then whether what is the cost of the battery based on whether they are costing of a battery, they are fixing based on the demand. That is also possible. Like foreign countries, they are fixing a pricing of the electricity bill like based on demand. That also analysis they can do. You can do as a research. Okay, this is one of the research we are also we did. We are published. We have published a paper in this. Then, likewise, various domain engineers you can involve. Not only electrical engineer, computer science engineer, all the engineers we can involve in this activity, like a MBA. If you are doing MBA, you can do analysis. Then where the charging station can be installed, how long it can be traveled. That analysis that can be done in this charging station architecture where it is employed. Then what is the future market about electric vehicles? Number of EV charging station around 20 up to 2026 they are projected in this is year-wise they are projected here. Then if I'm coming to the year-wise vehicle sales, okay, the last year 2022 they are telling about around 1 lakh vehicles they are telling about a range of vehicles they sold. Okay, this all from my side about a charging station architecture and standards of the electric vehicle. Okay, with this I'll complete my session. If you have any questions, please.
Yes, thank you, sir. Thank you very much for sharing overview on the various type of charging connectors and then various types of architecture which is followed in the charging station, as well as the importance of energy management in the charging stations. It is actually a wide domain, and we need a couple of days for covering in detail. And we have given an overview on this. Thank you very much. Participant, if you have any questions, you can post it in the chat or you can write. You can unmute yourself and you can write.
Any questions? Sure, we will share the PPT as well as.
And there was one question: what was the reason for decline in 25% during 2020? It is because of COVID or safety issues, or the frequent accident or explosion of battery?
Yeah. He is pointing out is correct. It's because of COVID only they are projection they are showing here. Correct.
Yeah, mainly because of the COVID only, and other things they are now addressing in the recent things. If you are going to see, the battery explosions are addressable one.
Also, I told you we are developing a vehicle. Then many questions I observed in the previous presentation also. Then how much charging capacity, which type of batteries I'm using. That and all we will address while you are coming for hands-on section. We will show you which type of battery we are using, which type of charger we can use, what is the charging capacity of the, what is the charging current of the particular charger. That that you can see practically here. Then, for example, if I'm taking a uh, bicycle that is of 250-watt motor we install with a 24-volt system, 24-volt 250-watt motor. Approximately, the current is around 10. Then you see, and getting by voltage, if you divide approximately, you will get the current rating. Then you must check what is my C rating of the battery, whether I'm using a 1C rating or 3C rating. That must we must clear. Then only we are can supply. Having a lesser charging capacity, I cannot provide more current. That current will damage the battery. That is the reason. Then many places the electric vehicle is happening. That they are keeping a vehicle in a very long time during charging, then the battery is overcharged. Then there is no provision for communication. Then if I'm going for a specifically AC charging, it will happen in two-wheeler one. We will plug into the electric vehicle. That will be creating a fire on the electric vehicle. If avoiding this one, we need to create a communication port for a in a level 1 charging itself. For that, we have to work.
Yes.
Okay, most of the references I have taken from my research work only. This is my research, one of my research work. The energy management is one of my research work. Then, if I'm coming to this different architecture, the paper is available. Review article is available. I will share you that review article reference also there here along with this presentation. You can utilize and many reference. For example, if I'm taking an isolated microgrid, I've taken 5 to 10 reference for the isolated microgrid. So based on that only, we conclude that this architecture is fixed for a particular domain. Based on that only, we fixed. Then general statement, whatever this general statement, then the video and all everything is taken from ABB website itself. It's taken. Then if I'm coming to this general statement and all, this we have taken from books and all, books and website taken.
Yeah. There is one question. One more question is that possible without battery system? Only PV and grid supply can manage energy supply to load.
Yeah, it can be managed, but we have to think of it how we are going to apply. If continuously battery swapping station, for example, I'm not going to install a battery energy storage unit in my charging station, but I can install a battery swap station. Then I can have a battery all the time. Okay, during afternoon session, if I'm not having any battery in my charging station, whatever the power production in my PV system, it can be wasted. Okay, that is the reason we must have a energy storage system in our PV installed charging station.
Yes, yes. So if you are going to utilize your grid supply mostly, then you can avoid the energy storage unit.
Yeah, directly
And
we
if
can
you
inject.
need a PV, then like you want to maximize the utilization of PV, then you need. Yes, I think the participant, the feedback link is posted in the chat. You can fill up the feedback link.
Thank you.
Yes.
Promotion.
Yes, sir. Thank you very much. And if there is any questions, you can write to us. We'll be happy to address.
Even the collaborative works also we are focusing. We are working on the conversion. If you are required any kind of conversion, you can contact us. Then battery development or any kind of help you require, you can reply. You can contact Narayanamurthy sir. We will be addressing it. Actually, we are working in the field of the conversion as well as then the energy management also we are working. That you can call us. Wireless also we are doing we did a wireless for the electric scooter, the skating board we did that also. We are developing a wireless charging that also we are doing. If you want to contact for the conversion, that and all we will be helping. That design portion we will be taking in last day. That time we will discuss everything. Okay. I'll give you. I forgot to give you my mail ID. You can write to us. Dominic J @ SRM ist.edu.in. If you need any kind of conversion as well as the energy management study, and you can call it. Then if doing a power conversion, then wireless power transfer application, you can contact us. We will help.
Yes,
We
sir.
can do
Thank
the
you very
collaborative
much.
work also.
Yes, participant, we will be sharing the material with you.
Yeah, everything I'll share. Too. Then research article, it's an open access only. I'll share.
Yes, sir. Thank you very much to all the participants. We'll be having the second day session tomorrow at 10 a.m. Please join 5 minutes early so that we can start the session on time. Thank you once again. Please don't forget to give the feedback link. From that only we'll be taking the attendance and other things. Thank you, sir.
Thank you, sir.